Given f of x is equal to x minus 4 and g of x is equal to 1 over x, we want to find f circle g and its domain, and then find g circle f and its domain. So let's start with the first one. F circle g of x. So here f is the outside function, g is the inside function. So we have f of g of x. Start with the inside function, g of x. G of x here is 1 over x. So this is f of 1 over x. This means that wherever we see the x in the f function, we put in 1 over x. So we have 1 over x minus 4. Let's get the domain of f circle g. So the domain of f circle g contains 3 steps. The first one is the domain of the inside function, which is g of x. So we need the domain of g of x, and g of x is 1 over x. So here we don't have square root, but we do have fraction here. We have fraction, so the denominator, in this case just x, cannot equal to 0. The second step is we want the domain of f of g of x, which is what we found, 1 over x minus 4. So here we have fraction. So again, the denominator cannot equal to 0. The final step is the domain that we want, the domain of f circle g, which is a combination of the first 2 steps. So the first step, x cannot equal to 0. The second step is also x cannot equal to 0. So this means that the domain that we want, x cannot equal to 0. So we have a number line with a 0. X cannot equal to 0, so there's a hole at 0 there. So our domain is from negative infinity up to 0, not including 0, so parenthesis, union from 0 to infinity. Let's get number 2. We want g circle f of x. So g is the outside function, f is the inside function. So this is g of f of x. Start with the inside function, f of x. So that is x minus 4. So g of x minus 4. That means that wherever we see the x in the g function, we put in x minus 4. So we have 1 over x minus 4. Let's get the domain of g circle f. So the domain of g circle f, again, 3 steps. The first one is the domain of the inside function, so the domain of f of x. And f of x is x minus 4. So here we don't have fraction, we don't have square root, so this domain is all real number. The second step, we want the domain of g of f of x, which is what we found, 1 over x minus 4. So 1 over x minus 4. And this here we have fraction, so the denominator cannot equal to 0. So here we need to add the 4 over. So x cannot equal to 4. Let's get the final answer, which is the domain of G circle F. And the domain of G circle F is a combination of the first two steps. So the first step, the domain is all real. The second step, x cannot equal to 4. So there's one restriction, x cannot equal to 4. So on our number line, we have the number 4 there. And we cannot have 4. So there's a hole there. So our domain is from negative infinity to 4, not including 4. Union 4 to infinity. Given f of x is equal to 1 over x, and g of x is x minus 5 over 5, we want to find f circle g of x and then its domain, and then find g circle f of x and its domain. So let's start with the first one. F circle g of x. So this is f is the outside function, g is the inside function. So we have f of g of x. Start with the inside function g of x. G of x is x minus 5 over 5. So this is f of x minus 5 over 5. That means that wherever we see the x in the function f, we put in x minus 5 over 5. So we have 1 over x minus 5 over 5. Now this one here means that we have 1 divided by x minus 5 over 5. 1 is 1 over 1. Division. So keep, change, and flip. So we keep the first fraction, change the division into multiplication, and flip the second fraction. And then multiply straight across. So this is 5 over x minus 5. So we have 5 over x minus 5. Let's get the domain. So the first step is the domain of the inside function, which is g of x. And g of x is x minus 5 over 5. So here we have fraction, but here the denominator is just 5. So 5 cannot equal to 0, which is a true statement. So here the domain is all real. The second step is the domain of f of g of x. Which is what we found. 5 over x minus 5. And for this one, we also have fraction. So the denominator x minus 5 cannot equal to 0. Solve for x. Add 5 over. So x cannot equal to 5. So get the final domain. So the domain of f circle g, which is a combination of the two domains above. So the first step, the domain is all real. The second step, the domain cannot equal to 5. So there's one restriction. We cannot have 5. So on our number line, the number 5, we cannot have it. So there's a circle there. So we have from negative infinity to 5, not including 5, union 5 to infinity. Let's get number 2. We want g circle f of x. So g is the outside function, f is the inside function. So this is g of f of x. So start with f of x. And f of x is 1 over x. So we have g of 1 over x. This means that wherever we see the x in G, we put in 1 over x. So this is 1 over x minus 5 over 5. So this is 1 over x over 5 minus 5 over 5. Split it up into two separate terms. So 1 over x over 5. This means that 1 over x divided by 5, or 5 over 1. So we need to flip the second fraction. So 1 over x times 1 over 5, which is 1 over 5x. So here we can rewrite 1 over x over 5 as 1 over 5x. And we have 1 over 5x minus 1. Another way of remembering this is we have 1 over x over 5. That means this 5 here is just going up with the x. So let's get the domain. The first step is get the domain of the inside function, which is f of x. And f of x here is 1 over x. So we have fraction here, so the denominator cannot equal to 0. The second step is get the domain of g of f of x. Which is what we found, 1 over 5x minus 1. And here we also have fraction. So the denominator cannot equal to 0. Divide out the 5. So x cannot equal to 0. So let's get the whole domain. The domain of G circle F is a combination of the first two steps. So the first step, x cannot equal to 0. The second step, we have the same restriction here, x cannot equal to 0. So that means the final domain, x cannot equal to 0. So we have the 0 there. X cannot equal to 0, so there's a hole. So we have a negative. So we have negative infinity up to 0, union 0 to infinity.